Hello. I'm going to be doing a virtual of round 642, and I'm going to be doing some commentary as well, since someone suggested it. And yeah, let's see how I do. Alright, yeah, some 10 seconds. Oh, I had to delete this. Okay. Give it to it. Okay, I guess. Non-negative, so you can make them 0 as well, okay. So, I mean, I'm guessing. So it looks like you can make it times 2. I'm gonna skip this one. I don't see the immediate answer yet. Um, okay. So you just want to swap out the smallest elements in A with the largest elements in B. Okay. And multiple test cases. So int n and k. Okay, int equals int n die equals 0 plus a scalar next int. And then I'm gonna sort shuffle A and shuffle B, and then arrays. Let's sort A and arrays. Sort B. And so let's see. Sums 0. Less than I plus plus if I is less than k, some, let's see, math.max between ai and b n minus I minus 1, well, sum plus equals ai. I think this should work. Now, okay, let's run it. Yeah, looks like I'm gonna submit it. Here. I'm gonna go back to problem A really quickly. Just check to see the third test. Okay, so I guess it's just try to make as many 2's as possible, and then whatever left at the end is probably yeah, I think that's there's multiple test cases. And we'll scan next. Long. So if it's even, then you can only make an even amount. So if n2 equals 0, else yeah, so everything will be twice except for the so actually I'm going to do if n is equal to 2 colon m, else if n mod 2 equals 0, then out.println or actually I guess yeah, I mean 1 is going to be skipped anyway. So you can have 0 or 2, 3, 4. Yeah, so the number of ones you can have double. Actually, I don't even need this because actually, yeah. Is equal to 0 is equal to m divided by divided by 2 minus 1, I think. And then out.println is equal to Hmm. To mod and divide by 2 plus 1. So it should be I'll come back to it. Okay. Okay. So if all of them contain one figure, I think the best thing you can do is try to get it into the center, probably. So, or actually, it doesn't. Or, yeah, since everything is a king's move away, uh, you can always get to a position by moving both your x and y by 1. And so, if we pick a random position like the top left, then probably should work. Or let's see, for 5 by 5. Yeah, if you calculate it for one row, then you should be able to get it for all the other rows, because they should just bust the same amount, just a multiple of it. So scanning in the size of the board. So it should move sum is equal to, actually I'll just scan in that same one. Let's see. If we have board size of 2, then it should just be n 1 time, yeah, 1 divided by 2. And then I think we can just multiply this by n. But actually, yeah, because you can just move the same way. But the only problem is when you move up So you can also just move to the left by the same amount. So you have to subtract out how many moves. So it should be something like it takes this much, then it takes n squared minus 1, n squared minus 2, minus 3. So I think it should be something like sum times sum minus sum. Does this work? Okay, that's clearly not the answer. I wonder why this overflowed. Wait, check to see. Oh, okay, yeah, this will overflow. That's definitely not the right answer. Let's see. If you move at least for a 5 by 5 square, in the first row it takes 1 plus 2 plus, or probably, yeah, you should probably center it at the middle. Or does it not matter? Yeah, I think it's best to just center it at the middle, and if it's odd, just pick any of the two spots. Okay, wait, it is guaranteed to be odd. Okay. Oh, that means there is an exact center. My bad. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and then if we find the exact center, then everything from the left should only have to travel halfway, and then, yeah. And same from the right. So it's basically finding just the normal distance. Of how many cells the weight is. And you take the minimum of, or the maximum of the x distance and the y distance. So in that case, yeah. So if you put it in the exact center, everything here will be, let's see, at most 1 away, and then 2 away. 1, 1, 1, 1, 1, 1. 2, 2, 2, 2. Okay, so yeah, it's just increasing some count. So you're just getting bigger and bigger boxes from first of size 8 to then of size 5 and then of size 16. So the next box size will be, what will it be? It'll be 6 plus 6 plus 5 plus 5, which is 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah, okay. So it just increases by 8 every time. And so you just need to do this progression. And how many times you do this progression is just based on which odd number it is. So I need to do 1, 2. I can't think of this is an O-N solution. I guess we could just store it in like a table or something, because it always just adds on to it. Yeah, we have 1 times 8 plus 2 times 8 squared plus 3 times 8, or yeah, 3 times, no, 2 times 2 times 8, 2 times 3 times 3 times 8. So it looks like it's just 1 plus 4. It's just the sum of squares times 8. Okay. And then I wonder if there's a closed form for the sum of squares. You can check. 1 plus 4 plus 9 let's check if this exists actually. 1, 5, 14, 14, 30. Let's see. Okay, it's a pyramidal numbers. Okay, so there's a closed form for it. Okay. Yeah, I'm doing really bad this contest. I'm not. Yeah. I don't know. I can't seem to figure out A for some reason. And I'm at the very bottom. But C doesn't look too hard at this point. So actually, it should be the pyramidal number apparently. And how far do we go? Well, first we get to 1, and then 3. So if I divide by 2 is 2. So if we get to 0, 1, 2, yeah, okay. So we just have to apply this formula. Yes. Yeah, okay, that works. Divided by 2. Oops. I don't know what happened. There you go. Divided by 2, and then done sometimes 8. I think this should work. Yeah, that looks like the correct answer. So let's submit. And yeah, we don't have to mod anything. So I think it should be fine. Okay, yeah, they've accepted. And 77 answer is pretty fast. I mean, it's all O1, so I guess it's fine. Okay, looks like a problem D. Guide action. Choose the maximum by length subarray. Continue sub only of zeros among all such that choose the leftmost one. Let's be LR if one is current action. The eye. Otherwise, my cell is even, and then so okay, this is an odd length segment, so the middle, the exact middle becomes 1, and then the next is we have 2's, of course. And then we just choose the leftmost one. Okay. Okay. I feel like we can just kind of brute force this by doing some type of link to list or something. Structure. Obviously, if it's all 0 at first, then yeah, you can just store the intervals and should be fine. So yeah, there's probably a smarter solution to this, but I think this will probably be the fastest. So we create an interval class. Interval is comparable. Let's start and public. A, B, and B. And then inter equals, since we want the bigger one, compare interval.end to start minus n. That is equal to 0, return integer.compare. Since we want the leftmost one, you can just do start interval dot start and return ref. And then we can just create a priority queue of these intervals. And okay, so we have multiple test cases, and we have our initial n, and we have our resulting array, and we need a priority queue to keep track of all these intervals. and we're just gonna add a new interval right here, from 1 to n, and then we're just gonna do while q is not empty. Because you know that when you place an interval in the middle, you can just divide it up again. And oops, it should be q.pull, and then int mid is equal to cur.start plus cur.end. If it's odd, then like 5, and if it's even, then we just choose the leftmost one, which is, if we had 3, 4, 5, 6, we would choose 3 plus 6 equals 9. Yeah, okay. So it's just, yeah. At 2, and int equals 1, so plus plus, and then we're going to create 2 new intervals. Well, if cur.start does not equal end, let's see, if we have length of 2 when we place it, then if mid minus 1, cur.start, q.add new interval from cur.start to mid minus 1, then if plus 1 is less than cur.end, q.add new interval from mid plus 1 to cur.end. I think that should be it, and then we set to print out our answer. So I, and then yeah, so we'll see how this works. Okay, that's doesn't look quite right. Or yeah, so if we place 1 here, wait, that's kind of weird. Right. Okay, so it gets until 2, and then it places 3 in the wrong spot for some reason. Oh wait, that's probably why. Okay, I gotta try this again, and hopefully it works better this time. Yeah, that looks fine. And yeah, I hope this doesn't time limit. It shouldn't, but we'll see. Okay, got accepted. My standings now. Okay, still not good. I still don't know how to solve A. Let's take a look at it again. Let's see. So my idea is you want to place as many 2's down as possible, and then yeah. So you want to be able to double as many possible, so you just have to count how many you can double, and then the next one is yeah, so you just want to divide it up evenly and try to double everything. Let's see. Okay, so if n is equal to, well, if n is equal to 2, we can't double it, so I'm just going to hard code those in. If n equal to 1, 0, else if n is equal to 2, else you count how many we can actually use to double. Log f equals, let's see, if n is even, n is greater than 2, then we have n divided by 2. In the case of 4, we have n divided by 2. Yeah, n divided by 2 minus 1. And if it's odd, then we have b. Then we also have, like in the case of 5, we have 7. So we should probably do something like n plus 1 divided by 2. Then evenly distribute them. Curve is equal to n by half. And left over is equal to n mod half. And then it should just be curve times half minus 1. That's how many times it evenly goes into there. And times 2 plus, and what's left over is curve left times 2. And let's see how this works. Oops. Let's forget about this. Okay, it looks like it works in samples. I think it should be fine. I'm not testing right now. Usually I probably test. But, okay, it got accepted. Better at least. But, okay. Yeah, not too bad so far. If I would have gone A quicker, I could have been probably much better off. See, if your argument in okay, so what I'm getting out of this is that if you, let's say I'm here and I move 3 spaces back, 1, 2, 3, I should get to, and it seems like just dp, where if we're at the ith index, you can just try to fill in the empty spaces, and then just do plus dp of, or yeah, or you could actually just start it off there if you wanted to, and then you just have to replace all of them. So let's keep a prefix of what we need to, how many ones there are in this current interval, something. So int k. So if we have our first prefix equals, and then our int dp equals n, prefix I is equal to si minus 0, prefix I plus prefix y minus 1, k, and then that takes care of that. And so we can just compute the dp pretty easily. Yeah, okay. 0 from and I plus dpi is just equal to, if we're going to place actually, yeah, dp 0 should just be equal to, should it be? Yeah, dp 0 should equal to actually we can just do this. So if it is 1, okay. And then if we start off at 1, dpi is equal to si minus 0 star 1 plus, so that's a, so this is assuming that all the ones, or wait, can we do that? Yeah, okay. Because we can have it if we don't have any turned on initially in the beginning before this index. So we can do plus prefix minus 1. Otherwise, let's see, if I was at position 1, 0, 0. So if we were at index 0, 1, 0, 1, 3. So if I is greater than or equal to k, I is equal to, and so if we want to just turn the first k minus 1, we could do like let's see. Well, if k equals 1, maybe, yeah, okay. So mathnomin dpi or dpi minus k plus and we want to change all the ones in between into 0, so plus prefix minus 1 prefix and minus k, and then we just have to check if we can make this a 1 as well. And then to check completely, you have to check the last k because that takes into account everything. So if we're at k equals 2, for example, and we're here, that does not include everything because you can still jump 1. So yeah. So probably math equals equals n minus 1, n minus 1 and n minus 2. For I is greater than or equal to n minus k, I minus minus. Okay, I don't know what happened there. It's math.min dpi, and then open the lines. And we'll see if this works or not. Okay, that is not correct. I wonder why. Okay, so if we have a period of 2, we can place 1 here. Yeah, it should only be 1. Let's isolate this case, and I'm just going to print out dp 0, 1, 2, 3, dp of 3. Yeah, so it is 1. Okay. And then, so this should be 0 or this should be 1 as well, right? dp5. For some reason it's 3. Let's see, not the dpi, dp I minus k plus prefix I minus 1 minus prefix I minus k. Yep. That's strange. We're pretending that we're at index I, or index 5. Let's print out prefix 4 minus prefix 3. Yeah, it's 0. So I don't know why. This is the 5th index, right? 0, 1, 2, 3, 4, 5, yeah. Let me just copy and paste this really quick. dpi minus k. Yeah, it's 0. So weirdly enough, and dpi minus k is obviously 1, so let's see. Yeah, it just became 3 for some reason. I'm not entirely sure why. Since we already computed at dp3, it's just... Unless I'm making a stupid mistake, probably. Okay, let's try and debug this. I minus k. Right, it's just 1. Wait, is it just because I have this XOR here? Wonder if... Oh, I have an error. Yeah. Okay, yeah, that was the bug. That was a stupid bug. Well, at least I found it. Okay, never mind, I'm still getting wrong answer, looks like. Okay, so in this last case, okay, so yeah, I need to account for the case where it's just 1, 1. Or when n equals 1, then obviously it's just 0. Otherwise, so apparently you can, a string of 3, you can just make it 0 apparently. Oh, right, because you can make it where that the rests are just going to be 0 as well. Oh, okay, yeah, I didn't account for that part. But I still don't know how I got a smaller answer here. But first let me take care of this one edge case. If n out.println 0 return. Okay, and then so probably we need to come do 2 DPs, one going from the left and one going from the right. Yeah, we probably have to do 2 DPs. So okay, so with this, I'll leave that left and right equals new int n, and then left 0. This is just, it should be the correct computation for going from the left. And then for going from the right, yeah, it looks like, I mean, we can just make the 0 as well, right? You don't have to make it 1. Or actually, never mind. We're trying to place a 1 here. Okay. So then right n minus 1 equal to s of n minus 1 0 xor 1 for int I equals n minus 2 for x greater than 0 I minus. I think we just copy and paste this kind of plus prefix of, so we're assuming all the ones to the right of this are 0 as well, so it should just be prefix of n minus 1 minus prefix I. Okay, and then otherwise we can do left or right. I plus k is less than n equals min. Let's see, right of I plus k, and then we need to get the ones between them, which should just be prefix of I plus k minus 1 minus prefix I. Okay, and then okay, have an n. The value I is equal to 0 for I is less than n. Here is equal to, also we could just make them all 0 if we wanted to, I think, which is just prefix. So we'll just make this prefix of n minus 1, and then do equal left I plus right I, right? Plus right of I minus yeah, you have to get rid of this overlap. Then as equals math.min here, print on yes. Okay, that's looking much better now. I think we're ready to submit this, and we'll see. Okay, got accepted, surprisingly. Let's check our standings. Okay, we're not doing too bad. so far. We're like at the bottom here because of our terrible A solve. And then I guess there's just one problem left. And yeah. Okay. So okay, you can move down to the right. Matrix of size n times n. And then okay, if the height of the current cell axis, you can move only to solve it with height x plus 1, okay? Okay, makes sense. The minimum number of operations you have to perform to obtain at least one suitable path from cell 1 to cell m. Okay, and then so at first glance it doesn't look that hard. Let's see. The number of rows and number of columns. So to me it just seems like it's just DP. I'm not sure what's so hard about this. Like you can just decide if you like if you're at some cell here, you can either choose to come from the top or from the left because you can only move right and down. You just take the minimum of those two. Yeah. So I'm not entirely sure what's too hard about this. Let's code it up. Actually, let's look at this first case here. So why is this? Oh, okay, I see. Well, actually, can't we just... Okay, I see the problem here. Yeah, it just looks like DP. And I get to use the longs because it can be up to 10 to the 15. And move on. And if we're into I is equal to 0, j is equal to 0 for j is less than m, j plus plus, mat j equals x long. And then we just have our dp. N times m. And then we just loop through. I guess we had to first initialize the first row in the first column is equal to is less than to m I plus plus if at 0 I dpi is equal to m at 0 I minus. Alright, because oh wait, but then it doesn't work because let's say you decrease, then you can't use it to come left anymore. That's interesting. So it's not just dp. So I'm guessing it's probably since you can only decrease, you probably have to start at very end first, right? And then you just work your way back. Yeah, you have to start at the end. Looks like instead of the beginning. And then just take the ones and try going left and to the top. Yeah, that should work. I don't know why I deleted that code. For I is equal to m minus 2 squared n equal to 0 minus. But that still doesn't solve. Or actually, I guess. Yeah, okay. So if you want to step to this path, and it's already smaller, or yeah, it's smaller than the previous one, then you have to decrement all the ones before it by 1. So that adds an extra piece. Okay. And then how do you keep track of? I guess like keep track of how many paths or how many steps you're at, because and that's just O of n m all squared. Yeah, okay. So yeah, actually I'm just gonna make this recursively because I think that'll be the easiest thing. And so then do this, and I will say memo, or actually we have to have 3 states because we're gonna also keep track of the number of tiles we step. So memo long n times n plus 1. And then, yeah. Raise up. And that should be fine because it should just be 100 to the power of 4. Actually, that might be too much. I mean, it's 100 million, we get 2.5 seconds. So if you run in time, j negative 1. Okay, and then like equals int current y position or current x position and our current number of steps. Okay, then just do if y is equal to and x is equal to minus 1, return 0. Okay, and then so if y is less than n minus 1, we can try to go downwards. Along here equals mat log x. X and next is equal to mat of y plus 1x. So if next is greater than or less than or equal to here, we have to shift everything down by the number of steps we've taken so far plus plus 1 because we're including this one as well. Equals divided by 10. Also, if memo y x steps does not equal negative 1, return y here is equal to long diff is equal to how much we need to ship down by, which is here minus next minus 1 or plus 1, and then n is equal to math.min and diff minus steps plus 1 plus for y plus 1 x plus 1. Otherwise, math.min and diff or that means next is greater. Next minus minus 1 plus rec y plus 1 steps plus. And then it's just the same thing, except we're going to try and move in the x direction. Mat y x less than m minus 1 x plus 1 and then it should just be y x plus 1 x plus 1 here, and then just return memo y x steps is equal to x. I think that should be it. And then doesn't look like we have to mod anything. Back 0 0 0. We'll try this out. Okay, so that's not quite right. So okay, so yeah, this works obviously. So I don't know how it's reaching. Oh wait, no, that is right. So how is it getting only 6? Like, if we're traveling here, just over to the right and down, it should just be let's see, to make this 3, 5, and then oh, it's probably because yeah, you have to make sense of the Now it's a little more difficult because in the second case where you actually manipulate the second one, that's kind of tough, because how do you know about more states? So I'd say maybe something like coordinate compression because it doesn't make any sense. Let's look at the standings really quick. I'm not doing too still. Doesn't look like any people solved it yet. Yeah, I'm not sure if I'll be able to get this one, but I'll try. Um, so what can we do about that? I guess doesn't matter. Like, yeah, the only problem is like how do you keep track of the steps and what you've changed so far without I can think of like an n to n times m squared or n times n to the third power, which is which is too much. So if you go to the right, then go down. Like probably you can just pre-compute. Um, but then that also makes it into 6 because you don't know where you're starting and ending. Yeah, because you don't know if it'll change or not. Okay, so Probably you can pre-compute the min steps already instead of having it as a DP state. So while you're going along, you can just calculate it. So, okay, well, I'll leave this here for 1 second. So for each of the n times m, you just need to compute how many possible values there can be. So as you go on, you just keep track of it. I think there shouldn't be that many values. Go to, unless I'm mistaken. Okay, and then we're gonna have to need. So our first thing is going to be min steps. Min steps. Actually, I'm not even sure if this will work or not. But I'll try that. Well, you can see at least n times. Yeah, I don't even think this will work. I mean, I guess you can try it. Like, first steps. And so I'm just going to try and compute actually how much memory this will take for my compression. Well, I'll just put it for actually. Then just move force. This one x. X. So I guess we just compress that to it. But then, yeah, okay. I don't know what I'm doing. That's not right. This one. I'm pretty sure this will not work. But I can't think of anything else for now. Just and then root 0. I'll print that one. Just comment this out real quick. Let's copy this. Oh wow, okay. Well, so apparently it's not very large. And I gotta write a checker for it really quickly. This is by. Let's see, 1 max. 1, 2, 3, random times max. So for that, okay. Why is it? Okay. Oops. We should go. Okay. Let's copy and paste it really quickly. And paste it in here. Wait. Oh. Yeah, okay. So 1, 2, 3, 4, 5. Oops. I did not mean to do that. I have to recopy all of it again. Okay. So how much time? Okay, we still have 20 minutes left. Oops. So it doesn't seem like the memory is actually too large. Like do something like. So I guess if we do something like using this compression, we can do something. So we can easily calculate the number of min steps to get here. Yeah. So we'll create a function called rec1 and try it out. Actually, yeah, this also min change. Just gonna copy over the entire function. And then one. So our current x steps and long val if Yeah, so we have to start at n minus 1, n minus 1. We have to start at the bottom right if we're going to find the min steps. And press that. Compress get or default. Yeah, should be val. Okay. So if y is 0, y is greater than 0, then we can move back one. So if the previous one is less than here, then it's kind of because you have to move forward actually in the process. Yeah, I think this might just be best computing it iteratively. So if we have it seems like a BFS actually to calculate the minimum number of steps here. So actually if we just start um, 8 y and x long about. Actually, we should probably make this like a hash. Let's see which time. I think this idea works. Let's see. We should make this a hash map. Times n. Yeah, okay. Then change J min steps. Okay, and then just 0, 0, 0, 0, 0, 0, 0 dot put q if min steps occurred y contains key cur val cur. So if cur dot y is less than n, I'm not sure if I'll be able to implement this in time, but of n plus 1, sorry, of cur dot y plus 1 cur. So if max is greater than or equal to val, val, well, that's of steps should just be steps. Dot y plus 1 output next comma curve dot step else not new steps dot curve dot x next dot contains should be just equals. But if it's greater than or equal to, then should be pretty easy. Okay, I just need to do this again. Okay, change all this. Oops. Check these changes right here. Then curve.x plus 1. I think that should be it. Yeah, it looks fine to me. So once we calculate that, we can have the long val int compress val equals actually okay, val. Okay. It should just be min steps y x dot get val everywhere where we see this here. I think this should be it. Hopefully. I'm not even sure if this will MLE or not. Actually, yeah, this is not right because we have to change the value, not the number of steps. So next, here +1. Just do next as well. And here +1. Yeah, I don't know why. That's weird. What is happening? It should also just be val. And then min change x.put. So I guess I don't really need this compression thing. Okay, I have 1 minute left. Probably has some bugs in here. Let's make this a long type, I guess. About punto line 0, 0, mat 0, 0. Try this out. I don't think I have it. I don't think I have it. Okay, well, let me just see if this null pointer exception. Okay, well, I shouldn't be getting null pointer exception. So let's look at my ending position. I ended up vision forfeit. It's not bad. Obviously, my A time saw is really bad because I'm really bad at math, but yeah, I'm gonna try to see if I can get F within the next 10 minutes or something. So why am I getting null pointer exception? I should have all the bases covered. It shouldn't be any different. Just doing this. So let's try this first case out. Again, number format exception. Oh, that's because I didn't copy the entire thing. Okay, so it correctly gets 9. What is it printing out? Oh, that's probably what's an issue. I should be not inside that loop. Let's see. Okay, this works now. And then let's see if it actually works on this problem. Might be TLE or MLE. Looks like it's running really slow right now. Yeah, looks like it's running really slow. Yeah, that time limit exceeded. Yeah, I'm not entirely sure how to solve this problem. I'll try to look into it later, but anyway, I hope you guys enjoyed the screencast. This was an okay contest for me. Well, the actual problems were pretty good, but I didn't do so good. Like, usually I probably want to full solve, but I guess problem F was kind of hard this time, and I didn't see problem A immediately, so that kind of hurt. Anyway, see you in the next video.